to come and join me. So I was asked by Kate in the PWI really to give an overview of a systems approach to railway and railway delivery, and that's really what I'm aiming to do today. As a brief introduction, my background in rail is circa about 10 years long. However, prior to that, I was undertaking systems engineering within the defence domain. Both highly complex, both advanced in terms of technological capability, etc. And I look back when I was making the jump from defence to the railway, thinking, oh, actually, the railway on the face of it seems less complex in terms of the systems, and really the aspiration I had was to develop that systems thinking piece, that systems integration that has been used and been used for many a year within the defence industry, and apply it to the railway to provide efficiencies. Increasingly, actually, there was two elements that really stuck out to me, drawing on the comparisons between the two. The first one being actually within the defence industry, there's no real need to interact and interface with members of the public. Something I've certainly learned within the railway industry, and that is one significant area of complexity that certainly isn't apparent really in the defence world. The second one being is the consideration of you build a boat or a helicopter or an aircraft or whatever, you put all the systems in it, you set it into service. Now, actually, in this industry and in the railway, we do all of that with the products we deliver. But in addition, an additional complexity that we have is we're doing all of that whilst also trying to maintain and operate the existing railway. And over the years that I've been in this industry, I think they're probably the two main challenges that projects seem to face time and time again. So, as it says here, opening systems approach to railway delivery. Initially, obviously, the question is, well, what is a systems approach? So that's one of the main topics to cover today, and why do it? And in doing so, there's articles and various evidence base that demonstrates and justifies the reasons for doing it. I then want to look at and cover what is that approach, and perspectives of the railway when viewed through the lens of three areas there of the funding mechanisms, of assets and systems, and then ultimately the functionality and capability of the railway and projects that deliver onto the railway. And then point three there, a quick overview, and it has to be brief and quick, I'm afraid, today, of how to go about applying some of that systems approach. And it really starts with actually considering, well, is it right for the project? Systems engineering, a systems approach is not going to be a silver bullet. It's not going to fix every concern, problem on a project. It's got to be considered. Is it appropriate to apply on the project, program or portfolio of work that we're currently working on? And then I'll give a few examples of typical outputs of systems engineering, of undertaking a systems approach. And in doing so, I think I'll be one of the first to hands up, really. The systems piece is very much, and I'm going to use the phrase, a desk-based engineer. The efficiencies in doing what system engineers and application of that systems approach is really all undertaken by processes, and development of products that then go on to satisfy the likes of justifications for a safety case, etc. So it's an approach that is focused on management of risk, and also then ensuring that the projects and the remits ultimately are achieved, and the benefits and the outcomes are delivered at the end. So why? Always start with why. So actually, the evidence base does go back considerable number of years. and that evidence base being both UK, as you can see on the left, and the McNulty, Henley, Bow reports all mentioned the challenges with management of complex projects, as well as actually other industries and even other nations. There on the right hand side, the Dutch civil engineering sector pushing for a systems engineering approach to projects. And finally, there are recent articles by the ICE, and I think they've now issued or soon to be releasing a part 3 of a systems approach to infrastructure delivery. So a few bits of reading if people want to go away post this. It's examples, it's lessons from where things have gone well, where things could have gone better. But yeah, really recommend looking up some of those resources. So quick thought piece, really, this one, and it picks up on recent incident, as you can see on the right hand side there. Individuals stranded over Christmas New Year period owing to flooding in the HS1 Thames tunnels. So again, very quick analysis. I'm not going to profess that I know the ins and outs of the problem, but really just to get a bit of a thought piece going here today. So disruption as a result of signalling problems caused by flooding in the Thames tunnels. That's really what the news was broadcasting initially. Actually, where was the source of that water? Two schools of thought, depending on which side you wanted to side with. But irrespective of that, actually, ultimately, it was an infrastructure failure, which resulted in cancellation, disruption. So for the purposes of today, let's just assume actually it was a leak with the fire control system, and as a result, and as no doubt everyone in the railway industry would expect, actually the lines had to be closed owing to safety concerns and safety risks. But actually, taking a step back and doing that systems thinking piece, could there have been other outcomes? Well, actually, could there have been services that were rerouted? Now, actually, the new trains, unfortunately, aren't gauge cleared for diversionary routes, which is strange because actually the older Eurostar services, as a result of the links that they had into Waterloo, etc., actually were route cleared for diversions to enable some traffic to not use the tunnels and still facilitate services to and from London. But obviously, the other aspect of that being actually the driver side and the ability to path whatever those additional routes are on, as we all know, an ever increasingly full and full to capacity railway that we have here in the UK. So yeah, okay, maybe there were options, but actually, it does take time to implement those options. It does take the desire and the will to do it. But the other concern really is ultimately is the likelihood of it happening and impacting the number of people that were there at the point in time, and actually the cost of doing so, and whether that's the cost of gauge clearing, whether that's the cost of redundant fire systems within the tunnels, and actually then again, and I'm it does come down to that cost piece. Would that cost have been proportionate to essentially the cost of disruption? After all, it's taxpayers' money that would have been used to install such a redundant system. So it's a bit of a thought piece there, really. Actually, are we targeting and are we ensuring that the railway systems that we deliver are reliable so far as is reasonably practicable? I would say yes, and I would say just in this particular case personally, it's just unfortunate of the timing of the event. But anyway, moving on. Actually, whilst that's an example within the rail industry, the challenges with delivering such mega projects, shall we say, be it HS2, be it Crossrail, etc. It's not restricted just to the railway industry. There's again quantum evidence that demonstrates similar. You might say Heathrow, you might say the delivery of the smart motorway systems, or even Hinkley Point C as a number of examples. Actually, they all have similar challenges. And what are those challenges? Well, actually, you could characterize the challenges around limited delivery time, about an uncertain delivery environment, what with governments changing, or certainly a general election every 5 years at least. Complexities around contractual interfaces. It's typically that would not be a single entity that is large enough to deliver on some of these major projects. So the contractual interfaces, boundaries, etc., and different drivers for different organisations play a key and crucial role in the success of these types of projects and programs. And that also then comes down to typically the mega projects being a sum of parts. Aspirationally, we want to achieve the sum being greater than the individual parts, and those parts being those smaller interrelated projects ultimately. So, as I said, common themes and challenges: the size, the uncertainty to do funding, complexity, certainly the timeline and the urgency, and then ultimately the structure, the structure of the railway industry being key, certainly in the domain that an awful lot of us operate in. And then finally, actually, as I said, just to highlight on those organisational structures, whilst they may be delivered in a joint venture, an alliance, in a prime contractor and subcontractor entities, it's typically not a standardised way of doing things, and all of those exist really temporarily for the life of the project or the programme. And if a contracting entity moves to the next one, they're typically not moved as one big unit who have taken the time and managed to work together in an efficient manner. So essentially, the systems approach, in my mind, what it's desired to do, and where I push it certainly within Sistra, is ultimately to assist with both the technical and managerial capabilities and complexities required to integrate at a system of systems, but also at a subsystem level. And what do I mean by those? So let's think about, what is a system? Well, if we're delivering a project, we'd start on the left-hand side. So irrespective of what the project may be, we're going to undertake, in the blue lines there, find the pointer up here, business or mission analysis. What are we doing with this project? Okay, well, actually, we want to increase capacity by 10,000 additional seats. Okay, actually, if we are going to do that on route, who might those stakeholders be? What needs are they going to have? Well, actually, it's not just able-bodied passengers we need to consider. There might be persons with reduced mobility. There might therefore be access considerations, etc., on the likes of those. Okay, so if we're doing that, actually, we're increasing the capacity on the infrastructure, but actually there are other associated systems with that. There's no good in 3-tracking, 4-tracking if actually we're not able to run additional services or trains. So there are the wider requirements definition needed of those enabling systems ultimately to demonstrate that we can achieve our additional capacity. And then that flows down in what us in system engineering fraternity characterize it as a V cycle. So you work down in additional increasing levels of detail. So down, start specifying, okay, well, my 3rd track, my 4th track, it needs to have a track capacity of this. Is it going to be ballasting? Is it going to be in situ, etc., etc. Get to the bottom where you're implementing it. So we're starting to actually I suppose, deliver, to build. And then moving back up the right hand side, okay, so we built the track. We now need to look at what does it need to integrate with. Okay, so there's the platforms and the stations in the vicinity. There's the likes of the environment that's going to be placed in. Delivering new tracks in Scotland would be very different to the environmental considerations of delivery of new track, let's say in California or in the Middle East, as an example. Moving all the way back up to then demonstrate through verification and validation, i.e. testing, through modelling, through analysis, that actually what we built actually achieves what we designed, but also in building that, we built the right thing. So actually, was it a railway? Was it 10,000 capacity, or actually was it merely a more efficient transport system? Asking those questions of did we build it right, and did we build the right thing ultimately? And then again on the right hand side, moving and transitioning into that operation and maintenance phase. So we started on day one, delivery of the railway, but actually, can we maintain the service provision, the performance, the reliability of that new piece of infrastructure that we've delivered, that integrates City A with City B? Or actually, are there going to be challenges such as highlighted in that HS1 article? So the systems V life cycle and systems process isn't merely around the consideration of delivery of a project. Ultimately, it comes down to how does that project fit in and operate, and ultimately at the end of it, how do you consider that you can then remove said project? And again, highlighting the difference from the defence industry into the railway industry, where actually defence, when they finished with a platform, it gets removed out of service. However, typically in the railway, we end up building or expanding stations with additional infrastructure to augment, and it's only through the likes of like renewals and replacements do we really dispose of certain assets. But again, replacement to ensure that the existing timetable, service operations, etc., can be maintained. And doing that and doing that last part well in itself has serious and quite significant challenges. So I highlight the blue V, but obviously within that, you've got to think of the context of where a project is delivering in. So above that, in highlighted across the orange, is out of, well, how are we doing it? Well, in Network Rail terms, there used to be the grip life cycle that was used, now translated to pace, but actually all of undertaking a project there in blue needs to fit in with the governance and the life cycles being applied in an organisation, as well as actually the management of the existing infrastructure. The blue, we're delivering a new project, but it still needs to integrate and operate, and we need to identify when we might need possessions to be planned in, to close the railway, etc., to allow the delivery of that new infrastructure. And it's not just infrastructure. If you take the example from Network Rail, the other aspects that they do is the likes of the timetable planning system. So their NR as an entity has got other considerations and other parties and internal stakeholders really that they need to manage. And obviously, any business such as that has got the likes of support services alongside and to support and augment the staff and the resources. But also the other consideration in all of this is some of the technical management processes, I've called it here, and that includes the likes of planning, of risk management, of configuration management, etc., as well as that acquisition and supply. So again, it's very infrequent that Network Rail might handle and manage and own and deliver a sizable infrastructure project all on its own. It would use suppliers, and it would require third parties to undertake analysis and delivery of certain aspects of such a project. I think finally down on the bottom, I've spoken about a systems approach and systems engineering. The aspect down the bottom here really covers off that, going back to what I mentioned earlier, it's not a one-size-fits-all approach. There isn't a single silver bullet that this is the way a project should be delivered. Actually, it's really important that there's consideration as to what level of systems thinking needs to be undertaken for a project. Well, I certainly could, two examples of a simple like-for-like renewal does not need the same level of systems thinking as the changes that were delivered as part of the upgrade to Birmingham New Street, as a simple example. I've mentioned perspective a bit, and quite a bit really, and actually I think this slide really highlights that well. It is a matter of perspective. So looking at our industry, looking at the railway, actually a few viewpoints that you could take. Firstly, is that of the funding mechanisms. So as you can see here, and it's an extract taken from National Audit Office documents, that actually the parties involved with simply operating the existing railway infrastructure. There's an awful lot, and the likes of the DFT and service operators, as well as the likes of the ORR, to ensure that the safety of passengers and members of the public is maintained and upheld in all instances. Then, of course, it's not just the infrastructure piece. You start introducing the likes of operators, Roscoe's, etc., etc. So, as a quick listing, as a quick example of some of those, a number of stakeholders there, and on the right hand side, and I really didn't have to think that hard just to elicit, quite a complex web of interaction between people. As well as, actually, if you think about the railway system, you could be breaking it down in almost I suppose an asset breakdown structure, or work breakdown structure if it's delivery of a project. So you've got the people element, and that includes the likes of operators, members of the public, and drivers who use, work on, maintain the railway. You've got the process part, so ensuring that there are franchises that are accepted and provided, that the possession planning and engineering works, etc., of the railway are all planned in, and finally that timetable planning process. Whilst it's owned by Network Rail, again, a great many number of stakeholders all vying for the same train paths and the same access, ultimately, to provide a service to their passengers. Picking on that systems piece, again, breaking it down into that next level of detail. You might say the infrastructure is one element, rolling stock being another element, and then the control system. So actually, how do you control the infrastructure? Again, another element. Whilst it's a simple breakdown, quite quickly you break these down into additional children layers, and actually what is in those civil structures. Well, you've got bridges, you've got tunnels, you've got XYZ, and then again, next level of detail, you've got the types of bridges, and obviously all of those with that bring in the likes of the maintenance regimes that they need to achieve and meet, etc. And then ultimately you've got the systems piece, and that's the functions and capability that is provided ultimately by delivery of something that's greater than the sum of the parts. So the cross-cutting themes of the likes of security. You can physically secure something, but actually if it's susceptible to a cyber attack, for example, then actually you're not going to be able to operate a railway system, and certainly not operate it in a safe manner. You've got the likes of the whole ops and maintenance piece. So consideration on a project, what needs to be maintained, what access might be needed to maintain certain assets, how would that access be provided, what periodicity does something need to be maintained, What might the mean time between failure be? Do I need spares on site? All of those sorts of considerations. Again, not dissimilar for any of the disciplines, but actually that system consideration as to if I need a 95% uptime or 95% availability of the railway, how do I ensure that is delivered through the designs produced on an infrastructure upgrade? Do I need redundant systems? Do I need to identify golden assets? Do I need those strategic spares, etc.? Do I use a bespoke element that is difficult to find spares for, or more of a commercial off-the-shelf solution, which again might be more readily available? And so again, three different examples and perspectives: the funding, the system, and the functionality one. And then moving on to, okay, so I've done that, I've considered perspective, but actually that applying systems approach, how might be a way to do it on undertaking a project? So obviously, for me, it's got to start with either the project scope or actually where there's an instruction to change scope. And that said, what I applied, what we developed within Network Rail as part of the systems integration for delivery framework was actually an assessment, and it took a number of considerations, i.e. the impact of complexity on the project, the urgency, so how quick might the project need to be delivered, as well as the likes of, am I delivering this project using product approved assets, product approved elements, or actually am I introducing new and novel technology as part of delivery of this project? And all of those parameters, considerations, allowed an outcome, one of three. Ultimately, actually, all this project is doing is, I'd say, a like for like in terms of form, fit, and function, replacement of existing. Okay, so actually that means that there shouldn't really be an impact to the railway if we're doing it, with making such a change. But it's important that I've given such a project that due consideration, and in doing so, actually there would be similar projects, and it might be a simple re-railing type project that is purely, actually, we're not fundamentally changing the capability of the railway. We've assessed it. It's not complex, therefore, and there's no impact to the likes of safety, security, etc. Maintenance regimes don't change. Or there are a number of projects, and probably quite a sizable number, over 50% of the ones that are typically undertaken by the likes of Network Rail. Yeah, it's a conventional change. So we might be things that they do quite often. Let's say a platform extension. So there are assurance and compliance that's needed, very much on a discipline by discipline basis, absolutely. But actually, what I'd suggest and what I'd argue is the mechanisms to do that are already written in with the likes of the CIV 003 standards, and so as a result, projects have got procedures in place to ensure that they do deliver and do deliver in a safe manner. And then finally, but for the last aspect of projects, or the last outcome being that of complex or novel schemes, and as a result, actually there is typically an awful lot more work that needs to be done up front to give the planning side, as well as the consideration of those outcomes and how we're going to achieve the benefits, the attention it deserves. And characterizing that really on the right is ultimately, when it comes to handing back your projects, have you got a compliance record that demonstrates I've delivered a project in line with standards, or actually have I worked and developed a generic and a specific application safety case, taking it through the likes of system review panel, SRP, and to the ORR to demonstrate that this project is delivering ERTMS between location A and B, as well as enabling the introduction of new rolling stock, and obviously all the compatibility considerations that come with that. Actually, here is that evidence to demonstrate, yeah, we're in a good place, we're ready, and we have considered unintended consequences of the decisions made during the design, as well as that transition into operation phase. So a simple example, and I picked, that of a changing out of a point machine. So that's really what the project is focused on doing. You could say, well actually, there's limited considerations here, but if we think about its context, it's in a particular environment. Going back to what I mentioned earlier, there are other assets very much nearby that it needs to interact with. So those other entities, the likes of a points heater. So actually that does provide the heating element to ensuring that the point machine continues to operate in an adverse weather type environments. There's the likes of how the switch interfaces with the blade, with the rolling stock, and how it needs power, etc., etc. So even a simple example, it starts to consider and gives those in the project entity, actually, what do I need to think about, and what am I actually changing as part of the project, merely to swap out the point machine? Well, as a simple, a number of simple interfaces there, or relationships, and you start to then think about which ones are within the gift of the project to change. So what is in the boundary of the project, and then what is some of those external entities, i.e. the likes of the environment, that really the project needs to be considerate of when they are making such a change. And that might be an electromagnetic or a particular temperature environment. There's nothing really the project can do, but actually does it need to demonstrate that point machine will still operate in certain conditions, and what are those conditions? Whilst that was a simple example of a context diagram, completely at the opposite end is one I developed here for delivery on Brent Cross projects, which you can see very quickly. Such a context of what's being delivered does become quite complex. This is a project that was being delivered over a number of stages or phases. So we've got work package 1 here, work package 2, 3A and 3B as an example. And what the project ended up using this for was not only highlight which of the disciplines, E&P, track, etc., were making a change at what stage in the project, actually color coding, and it was as simple as color coding just to understand what is the level of risk associated with certain elements. So the one there and the one highlight there in red, the one of concern, was actually, and I'm just reminding myself of, that's right, the train describer system that was being employed in this particular instance was going to operate under a trial certificate. So actually the focus on that, ensuring that the right conditions and the right application conditions of that trial certificate were met in the solution being installed within and being operated as part of the delivery of that work package. So on the one hand, the previous slide, again, a simple example, and this one very much different level of detail, but what I like to draw out is kind of that's that system approach really in action, and the ability to drill down from what might be a high level project all the way down, and I could drill down even into the next level. So what was specific to this work package being delivered had the next level of detail with interfaces to the likes of operators, maintainers, etc., all highlighted. So that's one particular example, an artifact that the application of systems thinking may deliver on a project. And the usefulness, I think, crossed anyone from the likes of the sponsor who found that the value in ultimately having a single sheet and a single snapshot of the scope being delivered by the project, and split into which work package we're enabling, we're delivering what. So that's very much on the one end, and even down to the likes of DPE and disciplines, who could very much look at how is the progress on a number of these areas, in terms of, I suppose, design, development, and delivery. And the beauty being, it's in one picture, and it's a a memoir or a quick check really of, oh, actually, I really do need to focus on that area because I've forgotten about it over the last few weeks. So it's just that check-in piece, and as I say, it goes back to the point I made regarding system engineering being that process and that paper-based engineering piece, ultimately to manage risk and hopefully remove some of the complexity of delivering some of these larger projects. Another simple example, and this is one that I took from my time at Network Rail, and it was based on a project up in the northwest, and the Trans-Pennine electrification was in development and an aspiration to achieve approval in principle back in 2017. And actually, in order to do that, quite simply, there was a number of strategies that needed to be developed, and ultimately, then the goals were set as to how might you achieve such a signal immunisation strategy, as an example. And as and when that you identified how you're going to achieve the goal, simple solution. So this very much became quite a simple representation on a top-down approach, and a sponsor could see, yeah, okay, I can see the progress towards the overall goal because I can see these solutions have, first of all, been identified. Secondly, actually, where one maybe wasn't going to achieve what was expected, you can quickly do an impact assessment that steps all the way back up to the top to say, as a result of this perhaps not doing what I thought it was going to do, am I still going to achieve that overall top goal? Really quite an effective tool, and again, a simple way and a pictorial representation of how requirements on a project could be demonstrated to be compliant, or as the case may be. Again, solely borrowed rather from a friend, applying a similar sort of technique on delivery of 18 trains per hour timetable as part of Thameslink. Very much a ready reckoner as to whether or not the timetable is ready, and has there been modelling, has there been that verification and validation step to demonstrate it is going to be proven to work. Is that the infrastructure ready? And again, a quick, very much yes, no, maybe kind of consideration. But as time progressed, thankfully, a number of the concerns and where there weren't plans and mitigations in place actually ultimately resulted in successful delivery of the project. And then finally, another perspective, another viewpoint, and this one being that of a migration plan, where a project, or rather a number of projects, are all aspiring to achieve ultimately the same goal of an enhanced railway service, whether that be reduced journey times, whether that be increased capacity, whether it be new routes. But actually, in doing so and mapping it out, what this migration plan does is it overcomes or tries to depict some of that challenge and complexity I spoke about earlier, with trying to continue to operate an existing railway whilst also introducing new. And in doing so, you can see the reliance across, whether it be franchisees, whether it be depots, whether it be actually the delivery of new rolling stock, is key and crucial to the change in the timetable ultimately to provide such a capacity enhancement and benefit. And then again, going back to that V life cycle, really as a summary of an outcome, really highlighting starting with that top level consideration, what are the expected, anticipated desires, outcomes, benefits, drilling it down in terms of the level of detail, undertaking that detailed work and development all the way up to demonstrate that at a I suppose a discipline level, and all the way ultimately at a whole system level, that actually we achieve said capacity and that we can safely operate, maintain whatever change to the infrastructure we're providing. And in doing that and providing this summary here, ultimately, you know, the key takeaways being application of this has really got to be tailored and be specific to the project that's being undertaken. You can go full-blown system engineering, but I for one would argue on certain projects actually that's not the right way to go. It is not going to be cost effective to do so on some of the more simple conventional projects that are being delivered, as well as actually that, you know, there are certain elements of those system specialisms that I spoke about, you know, system safety, security, etc., that actually how much of those need to be applied, well, it very much again depends on the project, and that's where the skills and expertise and capability of the likes of system engineers come in to really characterize what does need to be done on such a project. And with that, I say thank you for listening, and really do open up the floor to any questions, queries, and yeah, so thank you.
Thank you, Kevin. I think that was a great overview of what system engineer is and how it should be applied in the industry. So I think the project context diagram I thought was particularly good, sort of demonstrating how complex it really is when it is applied to live projects. Hopefully everyone found that really, really interesting. So I will kickstart with a question just to get the ball rolling, but please can somebody please do put your hand up, or if you want you can pop it in the chat and I can obviously read it out. So you mentioned at the beginning of your presentation you used to work in the defence sector. So my question is, what are the weaknesses of system engineering processes in the railway industry compared to in the defence industry? Is there any sort of gaps that you've noticed since moving over?
I think, yeah, and one of the big challenges really, I think, is it goes back to the point around it's an accepted practice and understood by an awful lot of people in defence. And I think really in the railway industry, it's still very much in its infancy. It's in a, you know, you talk to some engineering leads, heads of engineering, etc. They may have had a good interaction with the systems approach, or actually there are some projects where it's been trialed and it hasn't worked so well. So actually their view on what it is and the value of doing it on a project can be very, very different ultimately.
Okay. Has anybody got any questions on the floor that would like to put their hand up? I'm happy to ask another one, but I can reel them off, but please do put your hand up. Don't be shy, or like I say, just drop it in the chat and I can read them out. Okay, I think we've got a hand up. Hudson. Yeah, fire away.
Thanks, Kevin, for the presentation. Quite interesting. I've got a question regarding the number of interfaces that we have. I mean, don't you think that with so many interfaces the technical or the human interfaces, or the stakeholders, that introduces chances of making mistakes or errors in the system? Is it possible to simplify it? I was just thinking in terms of, say, the ownership, the DFT funds, and then the people who actually run the track are not the ones who run the trains, and all these sort of different configurations. It makes it a bit very, very complex, unnecessarily, in my opinion.
So absolutely, yes, it does. I understand where you're coming from, and I think it goes back to the slide I had around characterising that project. Actually, it's very simple to do such a characterization on interfaces as well as an example. So you might consider, okay, I've got interfaces with members of the public as an example, and actually they're all in the same camp. So actually, straight away, you can think, well, what are the interfaces with them? Well, obviously, I've got to keep them away from the railway assets, as an example. So irrespective of whether it's an able body, a person with reduced mobility, etc., what I do for each of those, actually, the interface is still the same. So when you're identifying them initially, yes, you can identify a great many, but actually you can quite quickly resolve those into, I suppose, common types of interfaces.
Okay, no, that's fine. Thank you.
Thank you. Okay, I'll ask another one while I'm waiting for people. Oh, Bashir, I can see you got your hand up. Would you like to ask a question?
Yes. Thank you very much, Kevin, for this. It was very, explanatory and full of information training or presentation. My question is, how can the awareness of project contributors be increased in the project? You mentioned about different sublots, like, under PWI we have track works, but in railways we have OCS, and it is really very difficult to know or to have the full awareness of those experts in terms of system engineering. What is your advice specifically to sub-STEM responsibles in order to increase their system thinking abilities, to increase the efficiency?
I think that's a great question, actually, Bashar, and that's one of the reasons that I jumped on giving this presentation today when Kate asked. That is one of my aspirations, really, is increase that basic level of awareness of much wider within the industry, but to a point where actually people are more than happy and confident and able to make that decision as to, no, the complexity on this project is such that I really do need to get someone involved and someone to assist with doing some of the more complex areas, like going back to Hudson's query around the interface management piece. At a certain point, the size, scale, complexity of a project tips from that simple conventional to one of more complex, where you might not know the outcome that's being aspired to. So actually, it's for me, it's the likes of this and the likes of Network Rail and through the application of DPEs and the consideration of project engineers and CREs undertaking systems, that hopefully that awareness improves and increases, even if it is just to that point where, as I say, DPE CEMs have the consideration as to whether or not they need to appropriately resource for systems engineering.
Thank you.
Okay, so we've got a question in the chat from Jay. He's asked, how have you found implementation of systems engineering principles and processes into the projects? He said, often in rail, systems engineering can be treated as an admin exercise at best rather than a guiding philosophy. So do you have any advice to help shift this and convince others of the value of system engineering in rail?
Yeah, thanks for that, Jay. I think my best advice, and it's through tried and tested mechanisms, really, is going back to my days of launching that SI4D framework in Network Rail. The advice I would give is, if you really are wanting to take such an approach, it's no good in instructing a project to do it. It's actually taking the time, sitting alongside the project, demonstrating to them the value of doing it, and actually what I found is turning some of the naysayers and the protagonists, actually, in doing so and taking the time and demonstrating that value, you turn them really into some of your biggest advocates, and then through that word of mouth saying, no, actually we considered all of these things up front, and it meant that, okay, it might take a little bit more in that early phase, but actually it stopped us at the 11th hour realizing, once we'd constructed something, that we had to do significant amounts of rework. So let's let's stay in the problem space for longer to ensure that actually that we get the right solution and we don't end up costing and whether it be, you know, jumping into a risk budget because we haven't considered certain factors or whatever it may be, but actually ultimately, you know, it ends up costing less and more often than not delivering on time, because we have had that considered, measured, systematic approach.
Okay, we got another question in the chat from Phil. So, to what extent should systems engineering be led by the client rather than the contractor? Can the contractor do systems engineering if the client isn't willing to fund it?
Thanks, Phil. Good question. I think in my personal experience, again, very fortunate. So whilst you know, did a number of years at Network Rail, now recently stepped back into a consultancy organisation. I'm still working a couple of days a week on the client side for Network Rail projects. So actually ensuring that they are very much doing it for what is, you know, Northern Powerhouse Rail. So it's a significant portfolio of work happening across the north. So we're ingraining it and embedding it very early on in the ES2 and ES3 phases to ensure that actually on this one, it does get flowed down as and when contracts are let at later stages. And again, it picks up my previous point of making sure that systematic approach is done up front, which again yields those benefits downstream. As to your second point, can the contractor do it if the client isn't willing to fund it? I personally would say yes. Again, sitting in that consultancy business as sometimes a contractor on projects, the argument I have is it's a way of managing risk. It's a way of efficient delivery of projects. So again, maybe not on all of them, because it does add, you know, some additional effort, some additional work, but actually ensuring that it's tailored, it's scaled, and it's applied to the right projects. I would say a contractor would want to do it to ensure that they achieve essentially the outcomes they expect within the price that they expect.
Okay, I'm going to ask a question. This is just one from my side. So with the amount of sort of complex projects that require system engineering, are you happy at the moment with the sort of the level of university education of system engineering in the UK? Is it enough considering the qualified resources that is required for future project opportunities?
Good question. Thank you again, Bashar. And I'm going to draw on an article a colleague of mine read from, it was either a LinkedIn one or something, it was over Christmas, saying that actually there were thousands of open positions for system engineers across all domains. Now, admittedly, some of those might have been for more IT systems thinkers, system architects, whatever it might be. But actually, I personally don't think there is yet enough, and I think it comes back to the aspects and consideration of actually where is it being applied. So yes, defence have got it, and they years ago rolled out a master's level apprenticeship in system engineering. It was very much focused in the defence industry, led by the likes of Thales, BAE, Lockheed Martin, etc. But now actually it's courses such as that are slowly, and I do say slowly, gaining attraction from a number of different universities to start delivering on you know, apprenticeships or bachelor, master's level type degrees. I don't think there's enough. I think the likes of myself and anyone who's, you know, vocal in the discipline could shout about it a little bit more and start asking those questions, you know, as well as an awful lot an awful lot of people that come into system engineering maybe haven't studied at university. And you know, my background was electronics, and I merely stepped into wanting to know more and more about a system when I was in defence, and that's kind of how I found my roots. So I think there's the aspect of the higher education, further education elements, but there's also an element of learning on the job, and that's where I see the role of likes of myself to try and really get to people and that broader understanding.
Thanks, Kevin. I think that's the last of the questions. I think Jay just put something in the chat about one of the rail systems engineering courses that runs at the Masters one. She gives a thumbs up to, so definitely if you are looking into doing it, check it out. It was the one I did, so I can definitely back Jay on that and say it's a fantastic course. But anyway, once again, Kevin, I want to thank you for taking your time to speak to the PWI about system engineering. As mentioned before to everyone, next meeting will be on the 8th of February, and that will be on the UK's longest viaduct. So that's the HS2 Coal Valley Viaduct. It will be a fascinating talk, so I hope as many of you can attend that. But as there's no more questions, I will now close the session. Okay, till next time, everyone. Thank you.